Hey everyone, welcome to this explainer where we are diving headfirst into the seriously confusing world of environmental testing standards. We see these marketing buzzwords literally all the time: waterproof, dust tight, military grade. But what do those actually mean for the survival of your super expensive gear? Today, we are peeling back the marketing jargon to reveal what your tech can actually withstand, based on the brutal, rigorous international testing it goes through in the lab.
Here's how we're going to break it down today. First, we'll decode the IP code. Then we'll look at extreme water testing, IP67 and beyond. After that, we'll cover impact ratings and NEMA standards. And finally, we'll demystify what MIL STD A10H really means. All right, kicking things off with Section 1, decoding the IP code and understanding exactly what these standard ratings mean.
So you've probably seen IP68 slapped on a phone box, right? Under the international IEC 6059 standard, those letters IP literally just stand for ingress protection. And that number? It's actually a two-part code. The first digit grades how well it blocks out solid objects. Think dust, sand, or even accidental contact with your fingers. The second digit, that's all about liquids. So it's not just one big unified score, but two completely separate lab tests elegantly jammed into one handy little code. Now, here is a massive misconception. What if you see an X like IPX7? A lot of people think that X means it totally failed the dust test. Nope, it actually just means the manufacturer didn't test for that specific criterion. They just skipped the dust test completely, but they did confirm it hits a level 7 for liquid protection. But wait, it gets better. There's fine print that almost everyone completely misses: supplementary letters. These tell us the exact crazy conditions of the test. See an M? That means the gadget was actually running and moving while they blasted it with water. An S means it was sitting dead still. So if you see IPX5S, an engineer knows exactly under what precise conditions that water jet protection was proven in the lab. Moving right along to Section 2, water testing, specifically IP67 and up. Let's talk extreme water survival. Okay, this is where things get super interesting. IP67 is a completely fixed off-the-shelf test. Your device gets dunked exactly 1 meter deep for exactly 30 minutes. Boom, done. But IP68, that is a variable standard, folks. The only real rule is that it has to be tougher than IP67. That means IP68 relies totally on whatever the manufacturer decides it means. Your phone's IP68 might mean 1.5 meters for 30 minutes, but a dive equipment manufacturer's IP68 could mean 10 meters forever. You always have to read that fine print. And if you want to talk about truly hardcore, let's talk about IP69K. This reading didn't even come from electronics. It started as a German automotive standard. It is not about gently resting in deep water. It's about surviving violent, destructive water. We are talking 80 degrees Celsius scalding hot water, blasting out of a nozzle at up to 100 bar of pressure from just inches away. This is the absolute gold standard for environments like food processing plants or automotive engine bays that get mercilessly pressure washed every single day. All right, on to Section 3, impact ratings and NEMA, because water isn't the only thing trying to destroy your tech. Enter the IK rating. People constantly confuse this with IP, but the IK scale, which is defined by standard IEC 62262, is all about taking a hit. It measures pure mechanical impact resistance in joules. Testing involves literally dropping a heavy steel mass onto the device. As you move down the scale, the impacts get brutal. If you see IK10, that is the ultimate guarantee against a violent strike. It proves the enclosure took a 20-joule smash. That's exactly like dropping a solid 5-kilogram mass directly onto it from 40 centimeters up, and the internal components still completely survived. Now, over in North America, we also have NEMA ratings. And you know what? You absolutely cannot just swap an IP rating for a NEMA rating. They measure totally different scopes. IP just checks the binary effectiveness of a seal. Is water getting in, yes or no? NEMA, on the other hand, accounts for real-world material degradation over time. They ensure that an enclosure like a NEMA 4X box won't just block water, it will actively resist corrosion and stay structurally sound even if it's literally encased in solid ice. Which brings us to Section 4, demystifying MIL-STD 810H. Let's really unpack what military grade actually means. We see MIL-STD proudly plastered on rugged laptop boxes and smartphone ads all the time. But I'm going to give it to you straight. If the spec sheet just says MIL-STD without listing the exact test methods, that claim is basically meaningless marketing fluff.
There is no single magic pass or fail certification for this standard. The absolute best way to understand this is the tailored suit analogy. Think of standard IP testing as buying an off-the-rack jacket. It's binary, standardized, meant to fit a general category. But MilStand 810H, which is the 2019 H revision, by the way, is a massive methodology framework. It's exactly like a custom-tailored suit. Engineers look at the unique, highly specific environmental stresses that a piece of gear will actually face in its real-world deployment, and they handpick specific tests from this massive framework to perfectly match that life cycle. And this framework is wild. There are dozens of brutally diverse methods to choose from. Gear heading to the Navy? It gets Method 509 for salt fog corrosion. Aircraft gear? Method 500 for low-pressure altitude. Or for the truly intense environments, Method 522 for ballistic shock. So, the crucial takeaway here is that no two military-grade devices are ever tested the exact same way. One might have only been tested for high humidity, while another survived an explosive atmosphere test. You always have to ask, okay, but which specific methods did it actually pass? To make things even crazier, the standard itself keeps evolving to be more unforgiving. Look at the transit drop test. Under the older Revision G standard, devices were dropped from 4 feet onto plywood-backed concrete. That plywood gave just a little bit of yield. But the newer Revision H drastically cranked up the severity, raising the drop height to 5 feet and swapping out that yielding plywood for totally unforgiving steel-backed concrete. It's a much harder test, ensuring that modern gear can survive modern operational hazards. So, there you have it. We've decoded the anatomy of IP digits, braved the boiling washdowns of IP69K, smashed things on the IK scale, and uncovered the bespoke, tailored nature of true MIL standard testing. Now that you are fully armed with the truth about what these standards actually demand in the lab, I challenge you. Go check the fine print on your own rugged devices right now. Does that expensive smartwatch actually state its exact IP68 depth limit? Does that rugged laptop list the specific MIL standard methods it passed? Or is it all just marketing fluff? Because when you're actually out there in the elements, the fine print is literally the only thing standing between your tech and total failure.
Like and subscribe.